All right. So here's the beginning of our videos. So sorry, I was having trouble making these videos. I couldn't open the slides for some reason. Something was wrong. But here we go. Before everything happened, we looked over frequency tables. Just a quick review. Remember, when we're looking at stats, we sort of have our 4 stages. First one is collecting our data. Second one is organizing your data. So one of the part of organizing was being able to put it into a table. So we looked at frequency tables. So that just depends how many data values fell within one category. And we did an example of a taste scale. We looked at an example of grades. So that means 4 students got an A, 9 got a C, 2 got a fail. And that was part of our organizing when we looked at the second part of statistics. The third part, within the second and the third, we talked about organizing your data. And you want to also be able to create illustrations. The illustrations that we looked at, let's see, let me start from the beginning. The very first type, we're looking at bar graphs. Remember, the bar graphs told us that the height of our bar is how many frequencies that we have inside one of the categories. So using the distribution frequency table, that's one way of showing your data as an illustration. It's also a way of organizing your data. But then we can also use pictures to help us illustrate these things. We also had a pie chart. And pie charts work great for relative frequencies. Remember, relative frequencies when we took the frequencies and compared them to one another. So remember, we have the total number of frequencies here. So if I zoom in, which I can, which is awesome, our total number of frequencies are 25. So that means if I wanted to find my relative frequency, then I would just take 4 divided by 25, 7 divided by 25, 9 divided by 25, 3 divided by 25, and 2 divided by 25. And that's how we did our entire frequency, relative frequency table, which was useful in a pie chart because a pie chart shows you once you put all those relative frequencies together, if you add all of those relative frequencies together, remember you're supposed to get a total of 1 or 100% because that means the entire whole, and that's how a pie chart works. Every piece in each column represents the entire whole once you put it all together. This was the example we did in class. And then we didn't, in some of the classes I was able to get to looking at a histogram. So let me zoom in here so we can see. And the histogram looks a lot like a bar graph. The main difference was that bar graphs, so I'll go back into a bar graph here. Bar graphs, these gaps here aren't actually meaningful. The only thing that's meaningful here is the height, because that tells us how many frequencies there are just in that one category. And here represent our categories. But if you look at this data is qualitative, where if we go back to the histogram, we're talking about quantitative data. That's why if I zoom in more, we can see that our categories are no longer just qualitative variables. These numbers are actually meaningful because we're looking at a data set that has annual energy use per person. So that's a type of measurement. And the measurement is like BTUs. The way you measure height is feet. The way we measure weight is with pounds. The way you measure energy consumption is in BTUs. So that's a type of measurement. And remember, anything that's numerically measurable is a quantitative data value. So here, these represent, sort of creates a window, because not everyone spends the exact same amount of energy a year, but people might spend between 2 to almost 300 2 to 300 million BTUs a year. And it sort of creates a window, which these windows, if we remember, are called classes instead of categories now, because it implies that it's quantitative variables instead of qualitative variables like a bar graph. So bar graphs had gaps in them. Their histograms also have gaps in them. But bar graphs, those gaps were not meaningful. These gaps on a histogram are meaningful, because if we see a gap right here between 7 and 800, if I go to my distribution table, that's because there are no data values that fall within 7 or 800. Similarly, 1000 to 1100, that's why we have this other gap, because no data values, no frequencies fall within that class. Or you can think about it as a window, so everything gets trapped inside. So these are one of the more common ways of illustrating quantitative variables is using a histogram. It's really popular. We will look at one later on, but for now, these are the ones that we looked at. So we did the collecting at the beginning of the semester, which was understanding a population, a sample, how to collect the sample. It was either systematic, convenient, stratified, cluster, or a random sample. And then we talked about organizing them in either in a bar graph or a histogram or a pie chart or using the frequency table. But now we have to look at some calculations. And we did some small calculations with this histogram talking about the class width and finding midpoints. Very small calculations. But the calculations we want to make now are in this next section. Go to the top. In 3.1, or 3.1 is called measures of center. So in some cases, it almost looks like we're getting the middle of a data set. So these calculations come after you did your collecting. So after you did your stratified sampling, you collected all this data, and you might have organized it all together in a frequency table, or you created a bar graph or a histogram. But now you want to make some calculations to them. And what calculations we're going to be looking for is we're looking for the average, which they also call it the measure of center. What the average again means, if we think about just the word in English, average just means the most common. And that's what we're going to try to look for. We're trying to find the most common data value. When I said I want, the example I use a lot in class was we want to find the average height of all PCC students. So that means you're trying to find the most common height of PCC students. What's the average? And there's a couple ways you can calculate the average. A lot of people always think that the average is the mean. So this is the first way to be able to calculate an average. A common mistake or misconception is that everyone thinks that the mean represents the average. And it does, but it's not the only representation of an average. We're also going to talk about the mean, the median, and the mode, which all three, and then we're going to look at a mid-range, the fourth one. All four of them could try to represent the best average possible, because average is just the most common data value. And these are just different methods to help you find the most common data value. And you can use each one in every situation, because we've seen that there's qualitative variables or quantitative variables. Quantitative variables have a numerical measurement, whereas qualitative variables cannot be measured. So you have to be thoughtful about how you're going to find that most common data value. And don't always resort to the mean, because it might be possible that you can't actually get the most common data value using the mean. And even if you could, sometimes it's not the best way to go about it. But let's see an example of how the mean is calculated. So you were able to see here, hopefully you read, the mean is found by adding all the data values and dividing the total by the number of data values. So for starters, if you're going to be adding anything, that's an operation of addition. So that means you have to be dealing with quantitative data values. You wouldn't actually be able to add qualitative variables. Like, for example, when we're looking at, if we're describing something as excellent, poor, or fair or poor, you can't add the word fair and poor and actually get a numerical value. So in those situations, when you're trying to find the most common response of either excellent, fair, or poor, there's a different approach to finding that average or the most common data value. But for quantitative variables, the mean is a very common one that's used. So let's look at an example. I'll get back to this idea of resistant in a second. I kind of just want to jump to the example. I know there was a couple slides before that are talking about notation, but I really just want to jump to the example. We saw that the direction told us to add all of these together, but for the sake of time, that's why I wanted everyone to get a calculator at the beginning of the semester. So if you have your calculators, take them out. And I'm going to show you how to use this calculator. Let me just back things up a little bit. So let me stop really quick before we get into looking at the calculator. Our goal is to get to this situation here. But if you notice, again, I did that kind of quick. I'll do it again right now slowly. But some of you borrowed your calculators from the library. It's possible that you have all these numbers here. That's going to make it difficult for you to actually input data values. So, for starters, when you get to the home screen, which is, it should be just blank, you can clear anything you want. What you're going to want to do is you're going to hit this second button here. Let me zoom in a little more. You're going to hit this button, because if you look at the calculator, all these buttons have little numbers or letters or symbols above them. Everything, if you notice, this has L4, L5, L6, and there's some that show up in blue, and there's some that show up in green. So that means either this button or that button, because blue is all the blue sort of operations, and green, here if you see green, it's mainly all the letters that you can try to spell out or write out. So to be able to get rid of all these numbers here, again, you're going to be at your home screen. You're going to hit the button second, and then right above the addition sign, you see MEM, which is memory. So I'm going to click that button, and this page should show up. So one more time. If you press this button, if you press the addition symbol without second, that's all you're going to get. That's me pushing the addition symbol. But that's not what I want. I want to be able to hit second, and then the addition symbol, and then you're going to get this list. It's going to be memory. You're going to go scroll all the way down to number 7, and then you're going to hit enter on the reset. Then it gives you two options. Either you can do default settings or all RAM. You're going to make sure you enter all RAM. So that's where, see how it's highlighted. You want to do that, and then you hit enter. And then make sure you go down to reset, and it should say RAM cleared. And then once we go back to our tables, you'll see that there's no longer any numbers here. So one more time, you hit second, plus, go all the way down to reset, you hit enter, and then you keep it the same, you hit enter on all RAM, and then you have to switch to reset, and then hit enter, and you should see a screen that says RAM cleared. Alright, so cool, everything's clear. One of the main important buttons we're going to be using a lot in this class is stat. And this is a stats class. So a lot of times I always tell students, they always ask, how do I get to my table? And I always ask, what class are we taking? The reason why I do that is because we're taking a stats class. So this is one of the buttons we use a lot of. So let me do that again so you can see what screen it is. I'm not going to put second and then hit stat, because if I hit second and then stat, that takes me to a completely different page if I were just to hit second. So see, second stat gives me this option, all these L's. If I just hit stat, now I have this edit, calculate, and test option, which we're going to be using these. So this is one of the most important buttons to know. We're going to hit, so let me zoom in, it's stat. So we're going to hit stat, and then you can scroll up or down where it says edit. We're going to hit enter, and you should see this table up here, and it should be empty if you cleared everything out. So let's do that again. We're going to hit stat, enter on edit, and then there's your table ready for you to input data values. So the way you input data values, you just type them up on your calculator, and once you're done typing it, make sure you hit enter. But you want to make sure you're not up here in this row. If you're going to start entering data values, you want to make sure you are on the very first row after those. You zoom in. They say L sub 1, L sub 2, L sub 3, which are the L sub 1s and L sub 2s and L sub 3s you see here on these numbers, which we're going to reference later. But for now, let's actually input our data. So if you look, our first number is 38.5. And then you can see the 38.5 there. Once you make sure it's right, you're going to hit enter. And your first data value will appear on your first column. Again, you can input your information on the second column, third, fourth, fifth. But at one point, you start running out of columns. So keep that in mind. But again, make sure you're inputting it in here. So our next data value is 55.6, and then you hit enter to actually appear on your column. Then we have 22.4, 14.1, and 23.1. Make sure that's right. It looks like I put 23 minus 1. It should be 23.1. Now that looks more like it. I'm going to hit enter, and then make sure this example had 1, 2, 3, 4, 5 numbers. One was 38.5, the other was 55.6, followed by 22.4, followed by 14.1, and lastly 23.1.